All right, let's take a look again at coding challenge number 3 with the tidyverse, this time on a computer where it is already installed. So, I've got my code that I'd set up yesterday with a few modifications, but let's go ahead and see how well it works. So, we'll clear everything out. We're going to load in the tidyverse. Now, I've already installed this, and once you do that, when you load the tidyverse with a line of code like this, you end up with this printout on the right saying, hey, it's brought in some stuff and conflicts, don't worry about that. This is as it should appear. All right, we load in our data. Now the tidyverse way of loading in the data with read_CSV, it's doing a few checks and it's categorizing different columns in different ways. So here, CHR stands for character, as in text. Double is a form of a decimal number. Population really shouldn't be that, but whatever. It'll be fine. It's treated as a number, that's good. The state code is treated as a word, which is good. So far so good. Likewise for the county flows data, looks good. Now I've got a few different ways to combine things here. And if you look at the help for any of these, you're going to get this help page. And we can see an inner join, everything in rows X, includes all rows in X and Y. What that means is if we've got X is pop, Y is county flows, it's going to include all rows for the counties and states that are in both of those data frames. Left join, it keeps everything, in this case in pop, because that's on the left, and anything that is also in flows that matches up with what's in pop, it keeps those. Right join, it's the reverse. It keeps everything in flows, and anything in pop that corresponds with that, it adds in. Sorry, that's left and right. And then the full join is where it includes everything that's in both, even if there isn't an overlap. So if you have sort of two data sets that overlap like this, inner join would only keep these rows, full join would keep all of them, and then would just have some NAs, some blank spaces for the places where there isn't an overlap. So when I run these, we can check what is the dimension of each of those. I'll look in the environment tab, and we can see 0 observations for the inner join. That's a little bit troubling. We'll take a look at that. I mean, you can see if we look at that, we just have an empty data set with column names, but with no data. That's a little bit disturbing. The full join, DF2, we've got 425,000 observations, which is more than we had in flows. Let's check this out. So 425,052 minus 421,909. 3143. So there's some sort of a formatting error somewhere. Something's off, right? We'll figure that out in a sec. There's always this sort of number floating around that 90% of what a data scientist does is clean data. Here we've got data that should be cleaned, but we're clearly running into some sort of a problem. And we'll dig into that. So when we do that full join, it's basically taking this big flows data and the smaller pop data and just kind of stacking them is what it looks like to me. Let's see if we can't see. So DF2, we've got Alabama, Otega County, we've got all this stuff. Let's scroll way over. All our flow data is missing. So we've got our pop data over here, and the flow data is not corresponding to that. So let's scroll down about 3,000 rows, if it'll let us. There we go, that's 200 rows. Let's go further in, here's 26,000 rows. So once we're further in, we can see we're missing the population data, but we've got the county flow data. So let's scroll up a little bit. I'll bet it's a problem to do with the state or the county name. There might just be like a space added after every part. Scroll up until we find where we're running out of this stuff. Oh, we're still at 24,000. We're going to have to scroll up a bunch. $1,600, $1,900. Okay, here is where we've got our switch. So we've got Alabama, Autauga County, but we basically want that first row from the pop data frame to be filling this in, but it's not. And that's certainly going to be a problem for the other stuff. And I might have to re-upload the data set, but we'll figure that out. So let's take a look at this. Let's go pop, we'll look at row 1, and let's compare that to flows row 1. So like we mentioned in the last video, if you watch that, there are different ways we can access different slices of our data frame. So square brackets and then a comma separated pair of values. The first value is the row, the second value is the columns. In this case, a blank means all the columns. So state A, character, 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 character. It looks fine. These variable names aren't in this other thing, so there shouldn't be a problem there. By default, if we try and put two data frames together, R is going to check the column names and see if they have any column names in common. It will use those. And it got that for state county codes, state county names, but it's interpreting these as very slightly different. So let's go flows. I'm going to show you a little bit of dplyr here. So if I go flows and then pipe into select, and then we use a function called contains, and I want to see what contains county A, capital A. So from flows, I'm getting those two columns, and then let's get the same from pop. And it looks pretty similar. I was right. So notice here, I, with my mouse, try to select everything, and it's just showing, it's selecting just this. And then here, when I try and select everything, notice it's got a little extra character here, just an extra blank space. For these, it's not as helpful. The formatting in RStudio, it's dropping, it's not showing a space here, but it's filling these in with spaces. So we can't quite double check on that, but what we can do is let's go ahead and load in these and compare what they look like. Okay, so in the file themselves, whoops, that's the wrong file, pop and county flows. It's a big file, it's not going to load. All right, let's do that in here. So if I go vim, county flows, Autauga County. All right, so it looks like it should be okay. Is this, oh, that's state B. I'm not seeing spaces after anything here. Another thing you might worry about is capitalization, although here it seems the capitalization is okay. Everything's consistent, right? If it was Autauga County with a lowercase c in one and an uppercase c in another, we would need to do something about that, because R doesn't know that a lowercase c is the same as an uppercase c. So this is a little weird. Let's scroll up and see if we can't get any hints from when we import it. So delimiter, that seems fine. Spec, whatever. Specify the column types. It gave everything the right type. All right. So I think what I want to do is I want to get rid of this space after everything in pop. Why did it give those to begin with? That is the question. Well, life's a mystery. So what can we do about this? We want to get rid of the pop, so I also have to think about how can I make this easy for you guys, but I'll worry about that after I get this working. So what I'm going to do is when I import pop, I'm going to make some modifications, or do I do that after? See, it should be doing the trick in here. Let's check pop.csv, take a county, no quotation marks, just straight text. It's picking that up all right. And then in county flows, straight text looks exactly the same. That is a real mystery. Here's how I'm going to do this. Let's use the by argument and specify what columns we're going to join on. So normally we say by equals null by default, and that means it's just going to say, oh, there's nothing, the user is not telling R what to do, so it's just going to look for common names. In this case, what we're going to do, and let me make sure I get the formatting right by checking the examples at the bottom. Blah, 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 blah. Can I find a by? I'm pretty sure it's going to end up being in one of these C functions. So if I do by equals C, and then what do I want? I want state AFIPS, county AFIPS. And I'm pretty sure I want those in quotation marks. Although I'm not entirely sure. Let's see if it gives an error. All right, so we still have an empty data set in that case. Didn't give an error. Let's check what I did before. Let's county A. Let's do this. Contains a FIPS. So when we look at county A from pop, oh yeah, we got a bunch of extra characters after that. And if we do flow, flows, we're getting a bunch after that also. Let me count this. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 characters, 11 spaces, so 0, 0, 1, and then a bunch of empty spaces. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Looks the same. Now, one possibility here is we could force these to be numbers instead of characters, do the join, and then maybe if we decide to afterwards, we could change them back to characters. It would be slightly annoying because we would lose this double zero, but it might do the trick. And our alternative is to find a way to get rid of this extra space after this. I'm going to try that first. So if I say pop, I'm going to experiment with the mutation here before I incorporate it into my code. So if I do pop, mutate, and if we do county a name equals county a name, how do I do this? I want to basically trim. You know what? I think there is a function called trim that will do this. Trim a character vector. This is from the glue package. Blah, 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 blah. Let's check the index there. Glue. We got a bunch of stuff. Single quote. Trim a character vector. According to trimming rules, blah, blah, blah. Similar to Python docstrings with the following blah, 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 blah. Trim X. So let's just try it. Let's try trim 001 space. Oops, not glut. It didn't work anyways. What I just did there with this little bit of syntax is to say, look into the glue library for a function called trim and apply that to 001 space space space. And it gave me back 001 space space space. Sorry, 2 spaces. But it kept 2 spaces, so that didn't do it. I think, is it... Oh, you know what? It's something to do with str. It's not str, which is about structure, but there is something like string trim. String underscore trim, which is in string R, which should be a tidyverse package. So if we do string trim 01, okay, that is gonna do the trick. So let's see, can I put a pipe inside here? Let's see what happens. It's giving us all that. And let's select county A FIPS, and let's see if it got rid of that space. Oops, county A name. Still has that space. So it's making me work for it. I just want to check to see what this all looks like. So let's try opening this in a spreadsheet. That seems fine. Notice here, LibreOffice has converted these to just numbers. Let's drop those zeros. So that might not be as useful a way to look at that as I had hoped. You know what I could do? Let's try this. Read underscore CSV. Let's force. Actually, I guess I could do pop mutate. Let's call this county A FIPS equals as dot integer county A FIPS. And then let's select contains FIPS. So notice it changed that to just this as opposed to the state, which we didn't convert, which kept that one. So let's see if we can't use that. So mutate county A. Is it just the FIPS that we were having troubles with, or is it the names? As integer county A FIPS. Just going to put this on a separate line just to make it easier. What do I want? I want to change county to state, and then I want to change FIPS to name. Put in our commas and put it all together. All right. Get rid of my highlights. There we go. So, it is introduced by coercion. That's not promising. Get rid of that. Let's do the same thing here. It is by coercion, whatever. Okay, look at that. Our inner join now, 421,852 observations. So, that is a little bit less than we started with. We're dropping 57 rows. I believe that that's probably one for each state if we're also including DC. I think DC's FIPS code is 11. Let's try pop filter. Select is to select columns. Filter is to select rows that meet certain conditions. So if we filter to where state A FIPS equals 11, DC, hey, look at my memory working. So there we don't have a county, and because we don't have a county name, we've got an NA. The county FIPS code is just 1, even though there isn't a name for it. That's weird. Let's try, what's New York? I don't think it's 34, but, ooh, it's actually pretty close. Is it 36? Oh, look at me finding FIPS codes. All right, so county name here, also not working. Oh, I know why. I can't turn a county name into an integer. All right. All right, let's try that again. All right, still a similar number, 421,595. So yeah, again, we're dropping something like 40. All right, cool. And let's try this for DC. The county name is District of Columbia. That makes sense. All right, so far so good. Our join seems all right. Let's look at just the top of DF1. Minor difference, the way data frames are displayed by the tidyverse is a little bit nicer, a little easier to read than in BaseR. There is technically a different data structure. It's called a tibble. But we'll talk about this more in the future. So we've got our stuff. It seems good. Let's view DF1. And we got population and we got flow data. That looks good. All right. So I'm pretty happy with this. The inner join or the full join or the left or the right, I think I'm going to go with the inner join. I'm not particularly interested in calculating data that doesn't exist, so the right join is not really something I'm going to worry about. The full join is going to potentially include some things where it's not in both, and we can see. Let's just run this again. Actually, before I go too far, run all 4 of those. So we've got 595, 912 on the full join, 598 on the left join, 909 on the right join. So what can we read from this? DF4 compared to DF2. DF2 has 3 extra rows, which means there are 3 rows from pop that weren't in flows. And then the left join, 909 912 compared to 598. And notice again, 5 versus 8. So we got 3 row difference between the inner join and the left join. And then, 400-ish between the full join and those. Let's view each one of them. All right, so what's our biggest one? DF2. This includes everything. Population seems okay. Let's see if we go B to A flow. I think by default it puts the NAs way down at the bottom. So we do have an NA that just looks okay. Doña Enya County looks like we've got a formatting error. It's not picking up the Enya, which you can't see in this video, but if you zoom way in, you'll see a little question mark. What should be Doña Enya County, and then a couple census areas in Alaska, which are also aren't showing up in the flow data. And that makes sense. Okay, so here are those three where something weird is going on. And population, Doña County has a pretty big population, but it's not spelled correctly in not the in the pop. It's not spelled correctly in the pop CSV. So, how do we fix that? Let's go ahead and load pop. Nope, there it was. Cool. So it's a question mark in this data set, which, gotta say, is a little bit questionable. If we go look at county flows and go to New Mexico, comma, DO, and here we've got that Enye. So let's grab that. Oops. Oops. Tab new pop.csv New Mexico DO. Huh. It's showing up here. So later in the semester, we're going to talk about working with text, but here we are working with text already. This is real weird. So in Vim, my text editor that I prefer, it shows up. In R's text editor, it doesn't show up correctly. I'm going to just copy that Enye over and see if that changes things. Let's clear everything out. Bring in pop, flows, join everything. I'm just going to comment that out for a sec. Have we got this 3-point difference? We still have a 3-point difference. So if we view df1, sort on anything, scroll down to the bottom and look for our missing data. That seems fine. Let's check. Sorry, df2, that's the big one. This is where we're going to see where we've got problems. So again, Doña County. We definitely are having problems with that particular county. I hate to do it, but I think the simplest choice might be to go into the file, the CSV, and replace all those Enyes with, just a regular N without the accent. All right. So, well, that's one weird mystery. And then what were the other ones? So if we look at this, scroll way down to the bottom again. Not seeing anything that looks out of place. Okay, so we still have our 3 missing ones. Again, those 2 in Alaska. We didn't fix that particular issue. Now let's look at where we're having problems with population. Alaska, Doña. So Valdez, Cordova. What was the other one? Let's just scroll up, see how far we go, if it'll load. Or not. All right, let's try. This way, and okay, so we are definitely not getting an overlap with the name. Or the FIPS code. Well, it's just not getting a proper overlap period. because it's checking all 4 of those, and it's seeing that whatever set of 4 we got in one, we don't have the exact same set of 4 in the other. Okay. Chugach census, Copper River census. Those were not the ones we were having problems with when we were looking at population and where we had NAs. Valdez Cordova is one of our problems. All right, so what do we do here? I think, well, you know what? This isn't rocket surgery. Let's just ignore the problem for today. Yeah, we're 30 minutes in. All right, this is going to be a bonus video. So, if we got these 4 possibilities, and I'm going to call DF1. That's the one I'm going to work with. So sometimes, you kind of make some alternatives for something you might use later on in your script, and then you select, I'm going to use this one specifically. So I've got the more generic DF as sort of a placeholder in my code lower down, and then I just specify, okay, specifically what DF should be is the inner joint. It's DF1. So now into actual tidyverse stuff 30 minutes later. So we're going to take that inner joined data frame. We're going to mutate. Our out percentage is going to be our A to B flow over population. In is B to A flow over population. And total will do the gross flow over population. There's the net percentage we can also calculate, but I'm not going to worry about that right now. And realistically, for your homework, if you get 1 or 2 of these, you're demonstrating that you know what to do. That's good enough for this. Again, the emphasis is the tools, not getting Tunya and County correct. If you work for the Census Bureau, you'd have to fix this, but we're not doing that work today. All right, so we look at that. Can I make that? DF has these mutations, good. And then our summary stats, we're taking that DF with those mutations, we're grouping it by state and county, and then we're summarizing. So for each state, county, each unique county, we are calculating the mean in rate, which is the mean of the in percentage, removing all NAs from that. So if we look at a block and we see 0.5, 0.05, 0.10 NA, we drop that NA because we can't average over a missing value. So we run that. No errors, that's good. Let's take a look at summary stats. So we've got numbers that look like the right order of magnitude. Let's look at this with more columns since we're in full screen. This looks right. Minimum is 0. That's pretty plausible. Let's look at, come on, R. There we go. Summary stats. Pull min in. And let's look at the maximum value. There's no such thing as summary stats. Summary stats. Okay, so we do have a minimum bigger than 0. What I just did there is I took the summary stats data frame and I pulled this column. So at this point, I've just got a vector that I thought was going to be all zeros, but I looked for the maximum value and found 0.00289. So there is some county where everyone's moving. Let's go ahead and see if we can't find that. So if we do summary stats, and let's go ahead and filter to where min in is greater than 0. State 48, county 261. Let's go flows, filter, state A FIPS is 48, county A FIPS is 261. Kennedy County in Texas. It's only showing up in 2 rows, so this is weird. What is the population? Population 346. So in this case, and I wonder if we'd use I think if we'd use the full join, we should get a bunch of zeros. So maybe, let's go back and let's change this to df2. Okay, so places where the minimum is greater than 0, we've got 4 rows where it's infinity. Obviously something is going on here. And then we still have this one where our minimum is this. So even with that, all right, so given that, and given our purposes today, I'm going to avoid indulging my curiosity and just treat it like that. So that particular, actually, wait, no. I changed my mind. I'm going to indulge my curiosity a little bit. Where was my filter for that specific county? Oh, that was flows, right? So even in flows, before we've worried about throwing away any data, it's just in there twice. So this tiny little county where some people have moved B to A to B. So one person moved to this county from Illinois. One person moved to this county from 7 people moved to this county from someplace else in Texas. 7 people, give or take 13. So really uncertain about this. One thing we could do in a case like this is we could look at that margin of error column and say, anytime that margin of error is bigger than our estimate, let's just throw that data out. If we were trying to learn something specific from this data set, we might just say, look, those are basically zeros. We want to know about places where people really are moving in and out of. And here it's just, the place is too small to really reliably do that. Why did these 7 people move to this county? Who knows? Nobody's moving out. So 7 people moved in from one place? That's kind of weird. Let's view this. Jim Wells County. Now I am curious. Oh, yeah, this is nowhere. So Corpus Christi, that's a real city. This is outside of there. They got some mobile home parks. They got a little airport. But yeah, check this out. The picture for Jim Wells County is a tractor along a dirt road. So not a super exciting place. And then Kennedy County. So look at that. Kennedy spelled incorrectly. And that is right over here. So we had 7 people move from here to here. That means some family bought a new house or found a cheaper rent or whatever. So not super exciting. This particular row is something we could safely throw out. But let's not worry about that. Let's just double check summary stats. And it looks pretty okay. Let's view that so we can be a little bit more precise. And let's scroll way down. We've got a few NAs, these infinite ones. Okay, so this is a little bit weird. You know what I want to keep also is population. So let's throw that back in. And population 2020. So let's call this pop equals mean population 2020 na.rm equals true, and a comma. Line up that formatting for no reason other than I'd like to see it lined up a little bit nicer. Let's see what warnings that just gave us. We've got some infinities. There in min. For each of those, no non-missing arguments. No non-missing arguments to min. Returning infinity. No non-missing arguments. So it's only got missing arguments, and therefore it's returning infinity. I'm guessing those... No, we did do an inner join. Oh, no. Let's go back to the inner join. Try that again. Okay, that time no warnings. All right, so let's view summary stats. Cool. So we've got population. Let's go ahead and find where we get our weirdest stuff. And it's all fine. All right. So that full join, because it had some things that didn't overlap properly, didn't work the way we would hope. But what we've got here, a little less than fully readable, but let's go ahead and fix that. But it's done everything we need to do. So let's change fips to name, and let's try it again and see if that's a little bit more readable. Cool. So, for example, if we want to know what is the least popular place to move into as a percentage of its population, Loving County, Texas. Let's see what that looks like. We're seeing some funny counties in Texas. Oh yeah, this is definitely nowhere. I've never been there. I used to live in Lubbock. I have done this drive from Lubbock across the state, but I haven't been here. I have been, I think, through the 10 in New Mexico, and I've definitely been in northern New Mexico. I've never been to here. But yeah, this is some arid stuff. This is, if Tommy Lee Jones was land, he would be Loving County, Texas. All right. So, what have we got? What have we done here? Well, we have stumbled over a whole bunch of little tiny errors, and we've pulled them out, and we found some weird things that maybe we need to fix, but we found a hacky way around that by converting to numbers to drop those spaces, which was slightly annoying, but it got the trick done. More importantly, we merged those two data sets together, and ultimately we decided to go with just the inner join, because that throws away a lot of rows that might give us problems, like we saw when we were looking at the full join. And when we look at what are the weird counties, even here, right, when you've only got 67 people in your county, some weird things are going to happen. It's possible, well, it's the case that nobody moved into Loving County in the year 2020. But 67 people, it's like, nobody moved onto my block this particular year because it's just a small group of people. Sometimes that happens. The mean out-migration, pretty high. Especially compared to, say, people moving out of LA County as a percentage of population. But if one person moves out, that's more than 1%. And I think that this is about one person. Let's check that real quick. So 0.0164 times 67, 1.098. Yeah, so one person moved out of Loving County in 2020. Gross migration of about 1%. Median in, median out. Obviously not very interesting for a tiny place. Let's take a look at what's the most popular by percentage. Kalawao County in Hawaii, but again, 82%. So 2% This is like 2 people moved in. It looks like a big percentage, but only because it's such a small base. So at this point, a little exercise to really drive this point home would be to visualize this. But I'm not going to do that now. We'll figure that out in the future. All right, if you watched this video, thank you, and I apologize this went on so long. Hopefully you had it on double speed, but this is a little insight into what actually happens when, the rubber hits the road. What are we doing when we're doing stuff? Sometimes we're just kind of poking through little minutia to make it all work. Now that we've got it working, we can apply this basic logic to other data. So if we were to get 2010 data, we can go back to the older census and use the same logic. And as long as the Census Bureau is formatting stuff consistently, we shouldn't have to do too much work at that point. And then even better, we leave this code sitting on a server somewhere, and then in another 6 years, when the next census comes out, we just load in the new data, hit run, and it should be pretty good to go. All right, so with that, thank you for struggling through with me, and if you have any questions, let me know. I'll talk to you in the future.